What are you doing?
Are both of you doing Duolingo?
I'm not doing
Why would I? But James.
We were doing Duolingo and oh yeah, I forgot you hate games.
Yeah, I also hated Duolingo because
Well, yeah,
so
Duolingo
annoying.
sucks. Yeah.
Hey, Jake. So you got like 2 minutes to get that wrapped up.
Oh, I thought they said Jake worksheets first.
Yeah.
That'd be funny. So in your Desmos, already assigned to you is an activity called limits and continuity.
That sounds
I thought it was
way too complicated for my feeble mind.
Yeah, I agree.
I really don't think it will be too complicated.
Well, then maybe they should name it something less complicated.
Yeah.
I'm gonna figure out a better name for it after we do it.
What vibe? Whoa.
Wait, does it involve graphing?
Yes.
Well, maybe some leader mouse.
So after we do our limits and continuity, then we're going to have another one, but I didn't want to assign it to you guys yet. I know I said 2 minutes, but I was hoping for you to be efficient, not use your whole 2 minutes that I said.
He's like, nope, gonna go right to that.
I said, I'm counting seconds. I like how you just tried to shut your
Am I
computer.
in the wrong
I'm not in trouble. Oh yeah, your habit is, okay, it's time for math. Shut my computer.
Yeah, and I realized that's actually what we're supposed to be doing.
Okay, limits and
And you guys can kind of discuss your way through this together because there is only 3 of us. I'm going to anonymize this just so it doesn't show your guys' names on the interwebs.
I want a funny name. Give me the funniest name.
I don't think.
No, it just anonymizes. So they are famous mathematicians.
I think I'm one of them.
Oh, wow.
Well, y value is about getting closer to its x approaches 1 to 2.
This is going to show us some new function notation that we have never seen before. Well, depending. Actually, maybe you may have seen it. I don't know. You do a lot outside of class. Well, have you ever looked at how to notate limits?
Probably.
Where you have a little notation beneath the function?
My teachers talked about it, but not a lot.
This is a really weird graph.
What sort of graph is it?
Piecewise?
Yeah, it is.
As opposed to piece dumb?
I'm gonna do that one.
So, your gut reaction, if I ask you right now, is this graph continuous? We said it's a piecewise function, but is the graph continuous?
No,
Like,
because
is it a
both of them are
function?
open circles.
Yeah, it's
But isn't there a closed circle to take the...
perfectly.
Now, hold on. Let's back up to some vocab. If it's not continuous...
No, but it is continuous.
Well, but if it's not, what do we call... I'm trying to remind us of vocab. We call it discrete?
Yeah.
I don't know.
Candace Price,
I'm asking you. You guys are smarter than me.
Candace Price, you might want to take
Summer, the math easy is good as violent.
I kind of bought last time, maybe, but everyone's talking
Oh
about
yeah,
it.
you're the only person
Yeah,
who's
I
not gonna
hate
see
that.
it.
I should just go watch it.
Well, listen to that.
What happens when you take classes over the summer?
Well, you're taking your class over there.
Yeah.
I mean, I could ask Mr. Hall if I could borrow that after they're done with watching it. Well, I mean, like, we could... They would probably... I guarantee Jake could occupy himself on his computer.
Yeah, I guess so.
Connor would probably just say, I don't want to do anything and watch it again.
Yeah.
I mean, if I'm trying to predict based off past...
That's pretty accurate.
Yeah, I'm thinking Jake would be on his computer, Connor would just be like, whatever.
Yeah.
Yes, I don't know what that means.
Now, make sure that you're reading the answers carefully, because one of these things is not like the other.
One of these things is not
Well,
the other.
no. We do not know that.
I'm so tired.
So, Candace Price, you might want to analyze if your 0.5 is correct. Candace Price.
Candace Price. You might want to check that out.
Candice P. Rice. canned dice. Pea rice.
Will we be watching any documentaries as well?
Would you like to? I was actually going to discuss with you guys. So we have like 14 days of class left,
Yay.
and I'm debating what to do with them. I actually today, for a moment, thought I wasn't going to see you guys, and then found out I was going to see you. So I wanted to talk a little bit about calculus.
Oh,
This is calculus. Yeah. So guys, what we're discussing here is gets into calculus. We could also, because you perked up with calculus, I could teach you guys a little bit about derivatives. Like here, just through a Desmos activity. I'm going to assign you guys a couple more things. Great, she says.
So wait, what are we doing for like the rest of the 14 days?
So let's get done this activity, because this shouldn't take us too long, the continuity activity. And then we can talk and kind of plan some things out if you would like. The documentary that I normally show pieces of is way too long to show the whole thing.
Yeah.
It would take us...
Watch one about cicadas.
Each disc has like almost 2 hours of stuff, and there are 3 discs. Yeah, it's a lot.
I feel like I'm proud. Wait,
No, I'm ahead of him.
yeah. Because it said your classmate's responses, and I didn't show your guys'.
Yeah,
Oh,
don't
no,
show your
that's-
guys' for mine either.
Yeah.
Oh. Yes.
Wow, Candace Price, your thinking is all over the place. That sketch, you're just getting more angry? Can we go ahead and move on?
Wait, sketch. Maybe I am more angry.
Yeah, what do we... What?
Change the graph. Wait, make it continuous. That means my answer was wrong? Okay. I guess I don't understand what the word continuous means.
So, maybe we need to go back and actually read the slides.
Well, I read it, but it didn't make sense to me, so I just kept going.
How is MA Olympics going?
It's great. I need to check what the event is for today. So, on slide 5.
I have no idea what it is.
I'm
On slide 5, it said if all of these values, the limit left to right, or from the left, so as we're coming from the left to the right, the limit from the right, so coming from the right to the left, and the actual value are all the same, our graph is continuous.
Okay, I just like to say I disagree with that way of stating that thing. That's a really lame way of saying that.
How would you state it?
I would say if there are no spaces or overlaps on the x-plane, then it's continuous.
On the x plane.
The x, the
I think every x, I think vertical line test gets passed here.
yeah, vertical line, exactly. Just do the vertical
But
line.
but what does vertical line test ask for?
All inputs have exactly one output.
Okay, I phrased that wrong. What is the vertical line test testing for?
Overlap,
What is it actually determining? Is this a blank or not?
function.
Function, not if it's continuous.
But how?
So this is one of those instances where we all got this wrong.
How is it? How could it be a function but not continuous?
That's what we're discussing.
Give me an example, please.
This is an example of a non-continuous function
How?
because it does not satisfy the criteria for being a continuous function.
All of those points have to be the same.
All of these values, the value of the function, the y value,
Why?
the output,
Okay, thank
the
you.
f of x.
Well, like the x is also a value.
Look, you're getting to the point in math where people do not say the redundant pieces. The value of the function is always what we're talking about as the output. The input is the input. The value of the function is the output. It is the y. It is the f of x. It is whatever else you were talking about. But we are never talking about the x when we say the value of the function. That is our input. that make sense? So this is an activity meant for kids in a calculus class who are more comfortable with us not being so explicit with what we're asking. But really, all of you need to go back and change this answer to no, because this graph is not continuous. Our values at x equals 1 are not commensurate. They're not the same. Now, you could also say if all three of these things coincide, right, are at the same place. So I was worried you guys weren't going to read and you were going to skip past this too
I
quickly.
read it, I just didn't understand it.
No comprendo.
Yeah, I
What do you mean?
I now understand.
I just don't understand why it's not continuous.
So I'm thinking maybe if you didn't spend so much time trying to scribble your entire screen to become blue and we spent a bit more time listening and analyzing, maybe that would be helpful. So sorry, going to call you out just because I need to.
This is continuous, but if this point is anywhere but that exact point where the other line stops, it's not continuous.
So
It's still a function, but it's not.
you went through these slides.
Well, if it's any point like on that, like if it's up here, that's a function, but it's not continuous because the points aren't the same.
The output value of that piecewise, we already agreed this is a piecewise function. The output value between here, here, and here, I think all those first three slides, if those do not agree with each other, if they are not the same, which obviously here, here, and here are not the same location, it is not continuous. So even if, instead of that point being separate, even if I filled this in and that point didn't exist, this is not continuous because it jumps. There's like a break in our function. Not like a gap, but there's a break. There's a jump. Does that make sense? This is why we're going over this. So you guys have a little bit of like introduction to continuous and not continuous.
so does math 3 consist of calculus? Is that what it is?
I'm not sure. I don't even have all the math 3 standards memorized, but yeah, you start to get into calculus very soon. And calculus is just a branch of math like algebra and geometry. I mean, it's just like, not necessarily. It's just what you're doing is then all of a sudden they're like, oh yeah, and this is calculus. Because calculus has to deal with as things move, as things go from one value to a next. So like periodics, that's calculus because it's as things move. So Candace, you should go back and change your answer to no because as we talked about, this is not a continuous function. Yay, Candace changed her answer.
We're all gonna have different answers for number 9.
Jake, seriously stop doing what you're doing with the draw tools. Like, I don't even have to talk to my 7th graders about that. You're being immature. I have an activity we're trying to accomplish, and you are working against me. Either get on the bus or get off. Metaphorically speaking.
The fake bus. Interesting. The big chose a different path. As x approaches 0, the left and the right limits equal 3. Oh.
So at least one of us read the directions of change one of the movable points.
Oh.
But it's okay if you changed both, because to make it continuous, we obviously dragged the 1 point down here to be
Yeah,
coinciding.
something like didn't really matter.
I know, they just said drag one.
I wanted to have fun. I'm sorry, Mr. Hunt.
No fun allowed.
Discontinuous
All right, so here's two examples of discontinuous at x equals -4. So Arhelia Rodriguez,
Who?
the anonymized Arhelia. That's you.
Oh,
No,
okay.
I never realized that.
And then Candace.
Yeah,
Candace made it even more complicated.
Yeah, it is pretty complicated there, Candace.
And then
I'm still working on it.
My open dots are really good, okay?
I hate drawing with a
A mouse
trackpad thing. Yeah.
Like, drawing with a mouse isn't all that fun either, but mouse pads are just the worst.
All right, so if you are done,
No, I haven't done the last problem. What?
Oh, burning daylight. That sounds more fun.
Wait, burning daylight?
Uh-huh.
How do you
hey,
burn?
wait, are you done?
No.
You didn't finish. What are you doing? You're on slide 9. Okay, you can skip slide 9 if the drawing part is taking a long time. But I do want you to go and answer slide 12.
That seems like a. So that's. That would be 4. Add some of the 4. Okay.
Did one of you take a snapshot?
Huh?
How do you know if someone took a snapshot?
I don't know. That's what I'm trying to figure out. Because it shows me a snapshot.
Of what?
I didn't.
So what do we do after we finish slide 12?
So only one of you on slide 12, only one of you thinks that function 3 is continuous.
Yeah.
So it's kind of a 2 against 1 right now. Function 1 and function 2 you guys agree on.
Function 3 is continuous.
I just remembered that when we'd always write that for piecewise functions, and considering that they had a break.
But it is piecewise, but it's also continuous.
So we said this is piecewise because it's
Right.
Why is it continuous?
Because the lines touch, the functions touch.
Yeah, if you plug in 4, which is both of their limits, that's 4 minus 2 is 2 squared equals 4, which is the same as
Oh, so they have the same value there. So even though the behavior is going to change and it is going to be piecewise, it's continuous because they have that same value.
Can it be continuous but not be a function? Like if it's one of those sideways parabolas? Is that continuous?
No, because I think when you break the function, you break its continuity. Because when we don't pass the vertical line test, now we have 2 different values that we're approaching.
Yeah.
Does that make sense, or you want to draw a picture?
No, I understand. Yeah.
Because yeah, we can break the vertical line test and break.
It was still continuous.
I'm not 100%, but I'm pretty sure if it's not a function, it's not continuous. Yeah, so 1, 2, and 3 are all continuous functions here. Very good. Let's really quickly, because it will be fast, go to functions and their derivatives.
Is that one of the things that you have?
Yes, I believe. If I didn't assign it, tell me, but I believe I did.
Is burning daylight going to be like one of the fun ones where we have the balls that go down?
Sort of. I mean, I don't know. If you guys decide that you hate it, then we can go look at a different. Here, I'll find the marble slides that would relate to the burning daylight one, and then maybe we'll do that marble slides first.
I want to do burning daylight. It sounds fun. I just want to know if it's going to be fun.
It sounds like the name of a sci-fi film.
Well, this one's f of x.
That's what I did.
Right?
I did the one that you had first.
This is going to be...
All right, we'll do another marble
Correct.
slides.
Let's go. Sorry.
Okay. Is that right? Incorrect.
Correct.
Try again.
Then describe how you decided.
I went through it enough times that you could hit
Process of elimination.
Okay. What about try again. What if we do it like
Wait.
What the heck is a derivative?
I don't know.
it's a part of a thing.
Okay, something derived. A word that derives from another one. A financial instrument whose value depends on the valuation.
How are you looking this up? I'm curious.
Huh?
How are you looking this up? Like Grammarly or what?
Grammarly.
I would do derivative of a function.
Okay.
Actually, I sort of kind of want to let you guys do the taco truck one too to see if you guys can get like the answer, because then I'm gonna give it to my 7th graders and challenge them that. Then I can say that you guys got it, how quickly you got it.
If someone told me that on a high school math who got it and we didn't get it, I wouldn't care.
No, but what I normally say is my 8th graders, and I don't use the word high school because then that feels. Yeah, I say, oh, my 8th graders did this in like 10 minutes, and they're like, oh, we can do this.
I want to do that. I want to make the 7th graders feel like they're bad at math.
What?
I mean,
You mean you want to motivate them to be as good as possible?
I mean,
It's all about
I'm
phrasing.
with Connor on that one. It usually does that.
All right, so I don't. Jake's not in here yet. I don't know if you clicked into the wrong one or what, which is fine.
Burning daylight, 'cause I thought that was.
Are we doing burning daylight?
No, and I can shut it down. You won't know how to do burning daylight yet. I'm sorry. I should not have assigned this. I should unassign if there's a way to do that. I just paused it so you can't do anything on it. So, what we see here, and we're not really going to talk about it much. What we see here is I did not anonymize
The
you
more
guys.
apostrophes, the smaller the wave gets.
So this f prime of x is the derivative of x. F double prime is the second derivative of f of x, or the derivative of the derivative.
Yay, so it's like squares.
And what we call these functions
Wait,
that are often known as like wave functions are, there's a word that starts with a P that is actually better for these things that go, they're periodics. So we're now going to go to marble slides periodics.
what is a periodic?
What exactly what we just talked about. What is also known as a wave function, like, or an oscillating function that goes back and forth, up and down.
All the stars. Wait, it says that that's not.
So the periodics one is not going to involve derivatives because I actually kind of did this out of order. So the periodics, we're going to like modify the periodic to help catch all our marbles.
Oh, so for the first one you didn't have to do it.
Yeah, the first one you just watch it.
Okay.
Woo, this is fun. This is pretty good. We call it.
Oh, it uses signs.
It's fun to just put the commas or apostrophes.
Does it do anything?
Yeah, it does.
What does it do?
It just makes it look wavy. So if
Oh,
I just did this, it just does that.
So wait, it's just shifting it?
Yeah, that way. Or
Well, I wonder how you can make it taller. Like stretch it to get
Move it
those.
to the side. If you add a multiplier to pi, it'll move it side to side without affecting.
There we go.
How can you stretch it taller? Did you figure that out, Jake? How can you stretch it taller?
You multiply the function that it multiplies by, like 5 sine, or 2 sine, or 3 sine.
Okay.
So wait, if we have,
Change the amplitude.
if I have this,
5 sine works.
If you have
oh, you said change this first multiplier. So the coefficient of your periodic, I guess, if we want to be like mathy about how we say this. So you said 5 sine works?
Yay, I success.
I think that should work.
I'm the only one back here on slide 2. Y'all are just moving on.
Come on, no.
No, no, no. Oh
Wait,
no.
I got the perfect thing. It's 1/20th.
How does that work?
It's
Oh,
basically just a
can't
flat
you
line.
move? That's
I'm gonna make it 15 though, I think.
Yeah, fix it number 2 seems a little awkward.
Yes, let's go.
You gotta make it basically a straight line, but
Yeah,
like,
that's
with a
what I
couple
did.
curves.
I'm gonna hide Connor's math, but this is what Connor made it look like.
Yeah, mine looks somewhat.
What? Wait, it didn't work.
So it worked for me.
Well, didn't
So
you
we have to
say
try it
last year-
again.
No, you said last year that it's different on different computers or something.
Oh yeah, sometimes like the ratio of the screen messes with it.
Moon Knight. Ooh, has anyone here watched it?
I have.
Do you like it?
Yeah, it's pretty good.
Oh yeah, so when I full screened it, then it actually worked. Because the ratio got goofy.
Yeah, I'm gonna just do this again. I just got rid of part of the function. This whole fix it number 3.
Using a decimal multiplier as opposed to a fraction. Fraction multiplier.
Yeah, you're so close. Okay. It's okay.
What? What is
I don't know what I just heard.
I heard something about someone's mother.
Fuck your mom. That's what they said.
What's the problem with that person's mom?
Right? Why we gotta bring a mother into this?
Work.
No.
All that made me think of is whatever song that is. It's like work. Come on, Desmos, work.
So these are like sine line function things.
Yep. And sine and cosine and tangent, I believe, are all periodics. If you'd like to test that hypothesis, you are more than welcome to.
Oh, this thing is not me.
This looks like it should work. Hey, it works.
Ew.
Wait,
Please. Oh my god.
All right. So with the fact that we only have 15 minutes left, we can come back to the periodics. But do you guys want to look at Taco Truck really quick and
Yes.
see how quickly you think you can get?
Yes, I want to make these small children.
I'm not great with these.
All right. So for the record, I am still recording because I might use it as an example of how you guys do with this.
Be sure to tell them that I'm.
Well, so here's the deal. You are welcome to work up at the board. However, remember, when you turn on an ink layer, it does not show up on the video.
Wait, oh, the taco truck is a 10 out of 10.
No. So the taco truck is one of these. We can work kind of together up here, but I would have to like click student. So go find this activity in your computer real quick,
Okay, got
like
it.
on your computer.
Start activity. Initializing.
Taco truck.
Alma is going to walk from point A to point B. Wow.
This doesn't
It's
sound
200 radical 2 feet.
It gets more difficult.
Can you put a radical 2 in here?
Click the little keyboard thing.
Oh, yeah. Okay.
Option B. Yes. Radical
Submit.
Whoa.
Whoa, we did it!
Alma
Okay.
walks 5 feet. Pressing good for you. Okay.
That number divided by that other.
Now wait, how did you know 200 radical 2 so quickly? Because my kids don't know those tricks.
Well, you just put 200 radical 2 and then they did it by themselves.
But how do you know that radical 2?
We know that it's a right triangle because we.
It's a what type of triangle?
And
Right
it's
isosceles.
an isosceles, right?
Ah, right. So it's a special right triangle, right?
Yeah.
So because this leg is equal length with this leg, that's what brings in that special rule that uses radical 2.
Imagine you're on the beach and you're getting hungry. I would never be
I
hungry
am
on the beach.
hungry.
Use the sketch to show
I'm
that
always
you
hungry.
take to the taco truck. You know, I would probably go up here and then go over here. One, two,
So Connor, why would you walk that route?
whole pathway
Oh wow, Connor. You
Said
listen to directions.
of the hot center.
Yay.
Wait, what do you mean I listen to directions?
He would like go on the walk way path, I guess. I don't know. Explain to me.
Daniel's going the way.
Wait, can I just say I'm really hungry and I want food?
Now.
Okay,
I mean, sure. Yeah, that can be your answer. It's like, I want food now. I'm walking straight there.
What information would help you know for sure? I already know for sure. Oh wait, how fast I walk?
Food. Great, I'm hungry and I want food. Oh, who's Daniel?
Their speed on the boardwalk is 5 feet per second. Their speed on. What? Why? Why would anyone feel like calculating?
Literally, like, oh well, you got there first. I just want food. Okay.
Okay, so we got.
I don't think I actually need to explain to you guys that no, you would never actually calculate this on the beach before you go get your
No,
tacos.
I wouldn't.
But in your future jobs, you might have very similar situations where you're having to do an optimization problem. Because are these two different pathways the only options?
No.
There's like infinitely many ways I could walk to the truck.
What are you writing, Connor?
I'm just putting in the equation because it does the math for
It
you.
does? Okay,
Yeah.
then I'm gonna do that. 5 to 7.
What is Margaret writing? Oh, that makes sense.
207 seconds.
Hey, don't just cheat. Maybe the teacher didn't just have the answer on the board.
Wait, what?
I put your answer up because I was curious about it, but I didn't realize everyone could see it.
Oh, wait, my answer? Oh,
Yeah, except you didn't have, how would you pronounce that name?
Bow?
Bao? That's what I was thinking too.
Yeah, I'm doing that one now. Square root of it. That entire value.
What's the answer? I don't see the
over
answer.
3.
Oh well.
Check my work.
What does it equal? That's not helping.
Check my work.
Oh, I can't see it. It's not really working for me. Oh.
I'm not sure what time that is, but it doesn't tell me if I got it wrong or right.
So, Margaret said 207 and approximately 196. Lynn said 207 and approximately 3.46 times 10 to the fifth.
I'm still working on that. Wait, did
I don't think that's the answer we meant to have happen, Lynn. So whoever is Lynn Conway,
What? I guess. I don't think there is a faster route.
How do I go to the? Oh.
yeah, I have you paste because I wanted us to stop and talk for a second.
About what?
I'll add one more screen, I guess.
Yes.
What? Oh, wow, that's a thing. I didn't know that. Okay, wait. Why can't I do this?
I'm gonna do that.
Yeah, so the question is if we don't just straight up take that hypotenuse of the whole triangle, is it better or worse? And kind of what would determine that, right?
I'm gonna do an interesting tactic that is very interesting and.
So Lynn, are you fighting with
No, wait.
typing it in?
No, wait.
You're just going to calculate it out now? Yeah, and quit trying to type it in so hard.
What is it?
5 seconds, or 5 feet per second.
About 196.
There you go.
196.
So here we all agree it's like 207 and 196.
When is the Pythagorean theorem like introduced in school?
8th grade math.
Really?
I mean, I'm introing it in 7th grade right now as a we didn't learn this yet, but it's fun.
Oh, okay. So they do know the Pythagorean theorem.
They're going to for this activity, yeah.
Okay. 'Cause you might beat that.
Yeah.
Just a little.
Use the movable points. Can't you just do the same thing that Bao did?
Well, if you do the same thing that Bao did,
You can get there at the same time Bao did.
Exactly.
so if I do something different than what Bao did, will it be less time, more time? Is there an optimal place to reach the boardwalk?
Taco truck.
If I do 327 right here, or 328, I can kind of use your guys' trick about radical 2 times 328, right? If I make these equal.
Wait, dude, Zoe got there first. I made a better route.
So wait, who is your name?
I don't know.
Why don't you check?
I can't.
It's under Taco Truck.
I can't
What's
check.
your name under
Mario
Taco
Margaret
Truck?
H. Hamilton.
I'm Mario
Okay.
Vasquez. What's the
You are Marguerite H.
Connor, you're Marguerite.
Hamilton. Marguerite Hamilton. Oh, you stole my idea.
What?
If we make these equal.
Wait, when did you say that?
You were probably zoned out. It's okay.
I think I did it before you said it.
You probably did. So you made these
I
equal.
I did it before you said it.
Yeah, just
And then, so wait, your next screen, you then calculated.
Yeah, and I couldn't just do radical 2 because they
Ooh.
used a decimal.
Ooh,
1,
we got
8,
10 seconds faster. Guys, that might determine if there's any guacamole left or not.
Wait, what?
If you're there 10 seconds faster and you beat that other person in line.
Okay, but you're 10 seconds faster moving at 5 feet per second, so you're 50 feet away, right? So you can
No,
always say,
isn't this the
"Hey,
total
wait,
time?
I want some guacamole.
Wait, isn't this the total time though?
But in the last 10 seconds,
Oh, you mean Bao could just yell?
yeah.
either of them could just yell and be like,
That's
hey,
not how it works. So you gotta be at the truck.
Ooh,
You can't be like 50 feet away yelling
so
things.
mad at Zoe if I was in that
Or you could
situation.
just sprint.
Yeah, you could just go.
All right, I'm adding more slides. I'm just gonna stop
You
the.
guac. You can sprint for it.
Best rate.
Now I really want some guac.
Yeah, I'm hungry.
I want Chipotle.
Press race to see how fast. The route.
Dang.
Oh no, I feel like I made a. Oh no, my route beat that one.
Zoe won.
Which
Wh-
Zoe?
Wouldn't you be so mad if you were that second
Yeah,
person?
literally. I would be
Like, watch, you're like thinking, I'm getting there faster, I'm getting there faster.
Oh, quick race, yeah.
And then meow.
It feels like you're closer. It feels like you're closer until the person on the boardwalk.
Literally, like, I would get so angry.
And now this person in the back gets no guac.
Literally.
No guac for you. So sad. Mad.
L, major L.
What each further expression means.
Ratio bozo.
Okay. Student uses Oh, you did all that work. Okay.
Did anyone find a faster time than 186? Because that was just an idea we had. I'm going to go back and reset to this one that they show us in this final slide. Or not final slide, but the one with the 100.
It's probably like halfway between them or something. Okay, is the best. Walk down boardwalk. Honestly, I think I'd be faster on this. Well, actually, I guess it depends on if you're wearing.
I can't tell who actually gets there first in this one that I just set up.
I think it's me.
Check it. So guys, you can go back to Zoe's path and change it. So I changed it to be like 222 of the boardwalk that she missed. And if I go back to the race,
Shouldn't the one that you have selected be the
I think I got there first with my 222.
Check, like, if it's like 100, if that'll get there before the 220. Oh, you probably can't.
Check if I make this 100, it'll change again.
Check. Oh my goodness, no. I don't want to. Oh, it's an extension. That means I don't have to.
So here's your 100 on like missing 100 of the boardwalk.
It looks like they're very far behind, but they're still behind.
Yeah, that didn't work.
I wonder if it's like exactly halfway between the two of them. Or wait, maybe it uses 3/5 or 5. It might be like 3/5 of the way.
So you're saying go like 240?
I don't know.
Well, because at first you said, what about halfway? Let's try halfway.
Yeah, but I wonder if it's 3/5 because like the sand is a third and the thing is a 5.
Mm.
Okay.
A 5?
10.
Okay.
10 is an extension.
Okay, so to be on the sand, I'm actually get out a calculator. 3 times 5.
Oh, that was close.
Is there a best? Is there a way to optimize this?
Ooh, it's time to go 100.
Probably.
Because my halfway between when I set, hey, you're packing up like a minute early.
What do you mean it's 16?
It's not supposed to be 6. It's supposed to be 18. We never printed new schedules, but it's supposed to be 18. Yeah, remember, because Perry has to have time to get out.
So, I don't know.
Well, that just means that Mr. Hall isn't paying attention. It's supposed to be 18 versus 16. So here's my true question I'm going to leave you guys with. Is there a way we can figure out the optimization of this? Because right now, my 243 and 246 seems to be winning against the other options that I've tried. Because it keeps showing me some of my other options as opposed to walking straight to the truck. And they're all pretty close, but my 224 seem to win. So I don't know. I'm curious. Is there a way to optimize this? I guess you can go since other people are going.
Do we have to do the extension?
Nah.
Okay, because I was like in the middle of doing it, but then it's hurt.
I'll leave it open in case you're bored in AO or whatever.